So I mentioned that astrophysicists are quite clever at basically squeezing all the information possible coming from celestial objects to, excuse me, to understand what's going on with stars and galaxies and the universe without being there. So one of the things that they have to know, or we actually count on every day, is that light interacts with matter. So light interacts with matter. Think about that. Now it depends upon what the matter is. So, for instance, light passes through a window, but it won't pass through your wool shirt, that sort of thing. So it has to do with what the matter is, but also it has to do with what the light energy is. So I kind of want you to apply this slide to kind of broader than just visible light, like from gamma rays to radio waves. What happens when those energies interact with matter, different types of matter? So there are some possibilities. In general, we could say that that either the object transmits, either the object emits light, okay, the object can absorb the light, the object can transmit the light, or the object can reflect or scatter the light. Now again, when I'm saying light, I want you to think of all of those different forms of electromagnetic radiation, because sometimes I have heard the term light really kind of really be meaning, instead of light, electromagnetic radiation, all forms of electromagnetic radiation. So here are some examples of how light interacts with objects. So for instance, when we turn on a light bulb, okay, basically that light bulb is in emission mode, emitting light energy. If we are wearing something black, okay, and we have sunlight shine on it, okay, what's going to happen with your black shirt is that your black shirt is going to absorb, your black shirt's going to get hot, okay? And so actually we're going to talk about how the color of an object is a player in what light does when it hits it. An example of transmission would be, like I think I mentioned, a glass window pane. Okay, the properties of that glass allow the light to transmit through. Okay, but actually glass would block some other forms of electromagnetic radiation. So again, depends not just on the matter, but also the energy, the specific actually wavelength or form of energy. The last one up there is scattering or reflecting. Okay, depending again upon the energy and the matter, that energy or light can be scattered. We're going to actually see the only reason that you, well, think about this, the only reason you see any object is because light is scattered off that object to your eye. Light is scattered from a source, light from a source hits the object and is scattered in all directions and you see it, okay? But now, there again, if you have X-rays or gamma rays, I mean, your shirt is probably not going to stop those energies. It's a property of both the energy and the matter. So here is to try to kind of emphasize this idea of seeing an object. So for instance, here's the sun. Okay, the sun is sending all of those different forms of energies. But if we focus on just the visible light, I'm going to go ahead and write Roy G. Biv. Okay, I'm just trying to emphasize the different components of white light coming from the sun. So all components hit this tree, okay? Notice that the green is scattered back, and so what is absorbed is so green is scattered, and what is absorbed would be Roy Biv. Okay, so Roy Biv is absorbed by this tree and green is scattered. So that's how that works. So we've got some examples then in here of different objects and different sources. Okay, so here we have, instead of just the sun, we have a light. Okay, again hitting this red chair. The red is scattered and everything else is absorbed, okay? So you kind of get the idea there.